Okay, so first things first, everything must be compared to 0 for the inequality, which it is. Second thing, you factor. Okay, so as we factor this out, in lead positions, we need a 5x and an x because that's the only combination that's going to multiply to give you 5x squared. The ladder positions, we got to decide, is it 3, is it 1, is it 1, is it 3? Looks like 3 here, 1 here would work, right? 3 and 1 would multiply to give me that 3. If I make this positive, if I make this negative, outside, inside should check out to give you that negative 2 back. You got your factorization. Now you take each of your factors, you set each of your factors equal to 0 and solve for x. This gives you what I've been referring to as critical values. So from the first factor, if 5x plus 3 equals 0, solving for x, subtract 3 over, divide by 5, get negative 3/5. Second factor, x minus 1, if that equals 0, then x is 1. Okay, we found our two critical values now that are going to kind of set up the boundaries for our answer. To figure out what our answer is, let's go back to what we know about this parabola. It's a quadratic. Apparently, it's got some x-intercepts at negative 3/5 and 1. And because it's a quadratic, it's a parabola. Lead coefficient is positive, so the graph opens up. The graph opens up, roughly sketched. It looks something like that. We want to see where this is less than 0. So less than 0, that's going to be below the line. That's going to be this corresponding part. Meaning we want everything between negative 3/5 and 1 to make up our interval that makes up our values of x. That would be our answer here. And as far as containing those two are concerned, it's just less than, not less than or equal to. We'll leave that open. But this would be our interval that makes up the answer. Okay, so another quadratic, everything's compared to 0, so we're ready to start factoring. Got a greatest common factor on this one, right? Got a greatest common factor we can take out of x. If you take x out, we are left with 5 minus x, all of that less than 0. You got your two factors, each of which we're going to set equal to 0 and solve for x. Solving for x, for this first factor, I set x equal to 0. I solve, I get 0. I take 5 minus x, I set that equal to 0 and solve, I get 5. So now I go to my visual for my parabola. I understand that it's got x-intercepts at 0 and 5. And with regards to the general direction that this parabola is going to follow, is this going to be a parabola that goes up or down? Well, you got to look at that x squared term, right? X squared term coefficient is negative. So this goes down. We pass through something like this. And since we're looking at the less than possibility, less than is going to be below that line. That's going to correspond to this part over here and this part over here, meaning my answer that's going to make up what these x values could be, that's going to be this interval here and this interval here. So those intervals are negative infinity up to 0. Do we include 0? We do? If this was equals to here, then we would. It's just less than. Form a union. We're not going to include the 5 for this portion. And 5 is going up to infinity. So those two intervals make up our answers for what x could be. Okay, on the last one, this is a little busy because we've got this compound inequality, so let me break this one up. Let me set up one inequality over here where I got negative 5 less than x squared minus 9. And let me set up a second inequality over here where I've got x squared minus 9 is less than 0. Okay, on this first inequality, we want everything to be compared to 0, right? So I'm going to add 5 over. 0 would be less than x squared, adding 5 over, that'd be minus 4. And just for perspective's sake, I'm going to flip this around. X squared minus 4 greater than 0. Okay, if I factor that out, got x minus 2, got x plus 2 because it's a difference of squares. Meaning my critical values over here for what x could be. From this first factor of x minus 2, x would be 2. From this second factor of x plus 2, x would be negative 2. Now let's go ahead and just focus our attention on finishing off this portion of the problem. We know there's a parabola here passing through at negative 2 and 2. With regards to the direction that parabola is opening, it's opening which way? It's opening up, right? Because the x squared term, the quadratic term, you've got a positive coefficient. So this is going up. Now, the portion of that curve we want as an answer, let's see, it's going to be greater than 0, right? That's why I flipped this around for perspective's sake. Since it's greater than 0, we're looking at these pieces up here, right? So right now, you've got these two intervals making up your answer. Since we've got another part of this inequality to consider, it might be a good idea to maybe start mapping out all your answers together on one number line. So here we know from negative 2 on over to the left, and are we including negative 2, by the way? No. So negative 2 on over to the left, that's going to be one possible interval of answers. And from 2 on over to the right, that's going to be another possibility. That summarizes the first part. Now, let's do the same thing for the second part of this compound inequality. The x squared minus 9 is less than 0. X squared minus 9, difference of two squares, so I factor as such. I get x minus 3, I get x plus 3, all less than 0. Critical values. Well, first factor of x minus 3 would give me 3. Second factor of x plus 3 would give me negative 3. All right, let's go back and let's build some more. Number line over here, playing with negative 3 and 3. Parabola, is it going up or down through there? Through those 2 points. It's going up again because quadratic term, you got a positive coefficient. So going up. Now, what part of that parabola do we want as our answer for this portion of the problem? It's less than 0, right? So you want, let's use a different color here, you want the bottom part. You want everything in here. So let me translate that down to my number line here. It's kind of my big summary. Got negative 3, got 3. For This guy up here, we decided everything between -3 and 3 would work, and it's just less than, so we're not including those. Okay, shading everything in between. So, we're talking about a compound statement where in the first place we wanted what's going on over here and what's going on over here. When we say and, we think intersection. So we got to take the parts here that are intersecting with one another. So take the overlap. Got some overlap occurring here, right? Got some red and blue coming together over here. So it looks like I got two little intervals of answers. I've got everything from -3 to -2, and those are open. I'm forming a union because of the second interval with everything from 2 to 3. Once again, open. That's what x could be. If you pick values on those two intervals, you plug back into the original inequality, you should get true statements back.